Good evening, everyone. My name is Sir Jude, and tonight I will be having the video lecture of our lesson this morning, which is about continuation of frequency and wavelength. But before we proceed to that, let's first recap the components of the electromagnetic spectrum. Starting from left to right, we have um, radio waves, mic microwaves, infrared, and then visible, which when dispersed becomes Roy-G-Biv. So R for red, O for orange, Y for yellow, G for green, B for blue, I for indigo, and V for violet. So after the visible spectrum, we have ultraviolet, and then X-ray, and then finally we have gamma. So because we're going to compute for the values of frequency and wavelength later, let's first review their trends, no? So from radio to gamma, frequency increases and wavelength decreases. So the number of waves increase while the distance or the length of the wave decreases. On the other hand, if you proceed from gamma to radio, frequency decreases and the wavelength increases. So the number of waves decreases while the length of the wave increases. So because in the relationship between frequency and wavelength, when one of them increases, the other one decreases, vice versa. Given their that kind of relationship, they exhibit indirect or inverse proportional relationship. All right. So now, we played four picks one word earlier, but of course with a scientific twist in that we identify the scientific component of the electromagnetic spectrum given the quartet of practical applications. So number one, you have food irradiation, wherein you're going to exterminate the microorganisms in food. Then medical equipment sterilization, wherein you disinfect and then clean hospital equipment and tools so that they can be used with other patients afterwards. You have PET scan, and you have knife surgery, which are very helpful in diagnosing diseases and um what do you call this, treating cancer and other deadly diseases. So what I'm saying is these four, they make use of gamma radiation. Okay, next, for thermal imaging, remote controls, CCTVs, and night vision goggles. So most of that for the four pictures, no, they're mostly used for security purposes, no, for tracking people. So these four make use of infrared waves. Now, for microwave oven, Bluetooth, Wi-Fi, and GPS, these four makers make use of the microwave. But Bluetooth, Wi-Fi, and GPS can also be accessed as possess radio waves as well, depending on the frequency and wavelength range that they embody, depending on the signal they emit. So next we have radio, television, cell phones, and satellites. So obviously they have radio waves. For tanning beds, forensic fluorescence, insect trap, and banknote authentication, they the common electro component of the electromagnetic spectrum for them is ultraviolet. And for microscope photography, lasers, and holographic projections, they emit visible light. And finally, for skeletal system imaging, bug inspection, welding inspection, and old painting restoration, they emit X-ray waves. So, as I said in the beginning of this video, now that we know the relationship between frequency and wavelength, and I just literally flashed to you some of the practical applications of the electromagnetic spectrum, it's time to solve for the actual values for frequency and wavelength. And this is where we need the help of this pyramid formula. So at the top is the speed of light in vacuum, represented by the symbol small letter c, which is actually a constant 3 times 10 raised to the power of 8 meter per second. So one of the properties of electromagnetic waves or the electromagnetic spectrum is that they can travel with and without any media. And it is uh this at the fastest when it's in vacuum. Now below the speed of light in vacuum in this pyramid formula, at the bottom left we have the wavelength with the symbol lambda and the unit meter. And on the bottom right we have the frequency with the symbol F and the unit hertz. So how do we make use of this pyramid formula? So let's have our sample problems. So in 2017, the University of the Philippines, Diliman, launched a broadcasting station called Lumad, which edifies the culture and struggles of indigenous groups. The station emits a signal of 2.45 times 10 to the 9 hertz. How long is this signal, and in what region of the electromagnetic spectrum does the signal belong to? So, in our pyramid, the most obvious number that we have to write is the speed of light in vacuum. That's 3 times 10 to the power of 8 meters per second. So in filling the pyramid formula, you must start with the symbol, followed by the magnitude or the value, and then the unit. So according to the second sentence, the station emits a signal of 2.45 times 10 to the power of 9 hertz. And because of the unit hertz, then that quantity refers to frequency. So we write that number at the bottom right. And based on the first question, how long is the signal? The quantity that we're being asked to solve for is the wavelength. And we have two values given already, one at the top and one at the bottom. So in order to get the wavelength, we have to divide the speed of light in vacuum by frequency. Using your calculator, so that's 3 times 10 to the power of 8 divided by 2.45 times 10 to the power of 9 hertz, that will give you 0.12 meter or 1.2 times 10 raised to negative 1 meter, which is actually very short. Ano? Ayan. So now that we answered the first question, it's time to answer the second question. In what region of the electromagnetic spectrum does a signal belong to? So to answer the second question, we need the help of the frequency and the frequency table. So how do we read and interpret this frequency table? So first and foremost, you have to look for the exponent in the scientific notation in the frequency. And the exponent is obviously positive 9. Then next, you have to locate the components of the electromagnetic spectrum which possess that exponent. And in that case, it's radio and microwave. Now, because this frequency is very specific, we have to look for one component of the electromagnetic spectrum only. So, we now have to settle on the coefficient. The coefficient of the frequency is 2.45, and 2.45 is less than 3.00, so that means this frequency falls under the radio spectrum, which actually makes sense because as you recall in the problem, this is a broadcasting station, and the best component of the electromagnetic spectrum dedicated to that is the radio wave. Okay, so let's have more examples so that you can practice. So problem number 2. That's a pair of Aita brothers audition in the voice generations last year. It's actually last year, not last month. The light technician focused a spotlight with a harmless radiation of 4.74 times 10 to the power of 14 hertz during one of the brothers' pivotal moments. How long is the wave of the spotlight? And in what region of the electromagnetic spectrum does the spotlight belong to? Okay, so naturally we start with the constant. So 3 times 10 to the positive 8 meters per second at the top of the pyramid formula, or rather the blank pyramid. And then we situate 4.74 times 10 to the power 14 hertz at the bottom right. So if we look back at the problem before we solve for wavelength, the light technician focused a spotlight. And we know that spotlight is a component of the visible spectrum. And the visible spectrum, when you disperse it or when you scatter the light, it has 7 colors. So that's a clue already that we have to choose one among the 7 colors that possess this frequency. But before we do that, we have to find the wavelength first. And to solve for the wavelength, just like in the first problem, you divide the speed of light in vacuum by the frequency. So that's 3 times 10 to the power of 8 meters per second divided by 4.74 times 10 raised to the power of 14 hertz, giving you 0.000000633 meters or 6.33 times 10 raised to negative 7 meter. Right. Now that we completed the pyramid, it's time to interpret the frequency of the spotlight. So remember, it's 4.74 times 10 to the power of 14 hertz. And according to the frequency range table, that falls somewhere along from infrared down to ultraviolet. But spotlight kasi is under the visible spectrum. And the specific color for that will be red. So why red? That's because if you look at the coefficient of the frequency, 4.74, that falls between 4.00 and 4.80. So that's why the visible component of this frequency is exactly at the red portion. Okay, so for the first two problems, we solved for the wavelength. What about when we solve for the frequency? So the third problem. A Muslim couple about to cross a street notices that only one color of the traffic light continuously blinks. The sunlight travels up to 5.32 times 10 raised to negative 7 meter. What is the frequency of the light, and in what region of the electromagnetic spectrum does the traffic light belong to? So, even though we're going to solve a different quantity for this one, there's no denying that the speed of light in vacuum remains at the top. While the value 5.32 times 10 raised to negative 7 meter, given the unit meter, that falls on the wavelength. So to solve for the frequency, all we have to do is just divide the speed of light in vacuum by the wavelength. So that's 3 times 10 raised to positive 8 meters per second divided by 5.32 times 10 raised to negative 7 meters, giving you the frequency 5.64 times 10 raised to positive 14 hertz. Now, if we look back at the problem, the object featured is the traffic light, and only one color of the traffic light continuously blinks. So traffic lights normally come in a trio. So, no? So you have red, and then you have sometimes orange and sometimes yellow, and you also have green. So you have to choose among the 4 colors wherein this frequency pertains to. So, using the frequency table, 5.64 times 10 raised to 14 hertz, it falls under the visible green category or spectrum, because 5.64, the coefficient falls between 5.40 to 5.80 times 10 raised to positive 14. Okay, so now for the last item, or last problem rather. In Northern Australia, the Aboriginals are renowned for their paintings of local animals and stories utilized with a certain region of electromagnetic radiation. The radiation extends up to 4.10 times 10 raised to negative 10 meter only. What is the frequency of the radiation, and in what region of the electromagnetic spectrum does the radiation belong to? So, first step in filling up the pyramid is we write the speed in vacuum, 3 times 10 raised to positive 8 meter per second. And then 4.10 times 10 raised to negative 10 meter falls under the wavelength. So bottom left. And just like what we did from the previous example, the third example, to obtain the frequency, we have to divide the speed of light in vacuum by the wavelength. So this is 3 times 10 raised to positive 8 meters per second divided by 4.10 times 10 raised to negative 10 meter, giving you a frequency of 7.32 times 10 raised to positive 17 hertz. So this problem is a little tricky compared to the first three because this one, the answer is not obvious. So what component of the electromagnetic spectrum is being used for paintings of local animals and stories in Northern Australia? So to answer that question, we need the help of the frequency table. So the frequency is 7.32 times 10 raised to positive 17 hertz. So the exponent, there's no actual range here that we're in. Set the exponent 17 is directly featured, no? But it belongs under the X-ray portion because if you look at the range for X-ray, 3.00 times 10 raised to positive 16 to 3.00 times 10 raised to positive 19, no? The exponent 17 falls between the exponents 16 and 19. Kaya, the radiation featured for the painting is none other than X-ray. Okay? Now, now that we're done, it's time to recap everything that we discussed so far in computing or solving for the wavelength and frequency. So at the top portion of the pyramid, which by the way, I will allow the pyramid formula and the frequency table will be featured in your examinations, in your upcoming performance task, and your upcoming long test sometime next week. No, I'm not a fond of having you memorize these formula because the real test or assessment of the skill, computational skill, is knowing how to comprehend the problem given to you and knowing how to manipulate the formula. So to recap, in this pyramid formula, you have the speed of light in vacuum, letter C, which is a constant, and then wavelength, the symbol lambda, and the unit meter at the bottom left. And finally, frequency with the symbol small letter f and the unit hertz at the bottom right. So we never solve for the speed of light in vacuum because that's a constant. So remember, to solve for wavelength, all you have to do is divide the speed of light in vacuum by the frequency. And to solve for frequency, all you have to do is divide the speed of light in vacuum by the wavelength. And basically, that's it for problem solvings involving frequency and wavelength so far. Now, I know that you are now overly saturated with too much information about frequency, wavelength, and electromagnetic spectrum. So tomorrow, expect a lighter load compared to the successive lectures that we had for the past 3 days. But till then, I am Sir Jude. Good evening and good night.